This is lesson 2 for today, understanding RUSLE2 inputs, specifically the first factor in the fundamental equation, which is climate, or R, okay? So this is the original USLE formula, the foundation of RUSLE2, RKLSCP equals A. Showed this in the previous lesson. And here is where the R factor, that first factor, shows up in a basic RUSLE2 profile calculation, right? It's step 1. You choose the location to set your climate. And again, what we're trying to do here is say, well, what do these terms mean, and how do these factors relate to sheet and rill erosion in the real world? Let's make this meaningful. It's just words right now. And so that's what we're going to do. We're going to dig into this factor. So let's get into it. Some top take-home points. The R factor is a measure of rainfall energy and climate erosivity for your location. Okay. The higher the R factor, the higher the risk of sheet and rill erosion. It means your climate regime has more energy for pounding bare soil and breaking apart aggregates, detaching soil, starting the sheet and rill erosion process, right? So the R factor for every location increases with the amount of rain, right? The more it rains, the more erosion risk there is. That makes sense, but it especially increases with intensity, right? The harder it rains, it's not how much it rains really, because if it just drizzles forever, but not too, it doesn't rain very hard, storms aren't violent, raindrops are not large, we don't get that much detachment energy. In the eastern United States, R values increase as we move toward the equator. I'm going to give you some examples of that, right? But it rains harder in the south than it does in the north in general. And for some Virginia counties, mountains, impact our precipitation or R values. So, the Shenandoah Valley is kind of in a rain shadow there. There's not as much rain in the Shenandoah Valley as anywhere else in Virginia. So we may have less erosion risk in the valley relative to, let's say, Lee County, Southwest Virginia catches more rain. And so we actually have a very significant mountain impact for some Virginia counties. But the key idea here is that, there's one set of climate data per county in the eastern US, okay? So what that means is, let's say one of you works in one county in Virginia, or maybe 2 counties, but every field in your county is going to be assigned the same climate by RUSLE2. So it's kind of like it doesn't really matter. Why does it matter to me? I only work in, let's say, Augusta County, and all my fields have the same climate in RUSLE2. And there's little difference between adjacent Virginia counties, but I still think it's useful for you to understand some background. One other thing to point out is that now, unlike the earlier versions of USLE, RUSLE2 actually uses 365 R factors. So while we can have an annual factor, which I'll show you in a moment, RUSLE2 actually does an erosion calculation for every day in the rotation, the crop rotation that you model. And what that does allow us to capture seasonal differences in erosion risk. For example, the idea that in Virginia, our highest storm intensity is in the summertime. So let me show you an example to try to flesh all this out, because there's a lot of words here. So here's a first example, right? Precipitation amounts versus intensity. So this diagram, it's simple, color coded, showing you basically the idea that the colors in this, you go up and down the eastern seaboard here, the colors are about the same. Certainly, much more similar than if we went to Louisiana, right, or down into this region of the south where it's a lot more rain, or we go here to the west, right? And so basically, our rainfall regime ranges maybe from a low of 30 to 50 inches per year, right? This is average annual precipitation. And so, yeah, there might be a difference of 50%, that sounds like a lot. Here is a map of RUSLE2 R factors. Okay, and it does come from the manual associated with RUSLE1, but these numbers are similar to what you'll find in RUSLE2. And what do we find is that when you move down the eastern seaboard, where we might have had a change in in erosion risk of, in total precipitation of maybe 50%, right? Maybe went from, from 30 to 45 inches of rain a year. When we go from Maine with an R factor up here, roughly 70, annual R factor, overall R factor of 70, down to Georgia, let's say an R factor of 400, right? That's a 500% increase, not a 50%. So intensity increases as we go south. And I really like to use, a specific example to help us understand, I can extract climate data for each county in the US from RUSLE2, or at least the eastern US. And I did that for 4 counties. I took Aroostook County, Maine, which has 39 inches of precipitation a year. And I also went down to Bacon County, Georgia, which is 49 inches of rain. And I also modeled Rockingham County and Sussex County, Virginia, right? And you can see that there's not that much difference between all these, really. And I've graphed, the inches of precipitation. So this is not intensity, this is just total inches of precip on average in the weather record that RUSLE2 has across the year, right? Total precip. This is a graph of the R factors, right? And what it's showing you is that Aroostook County, Maine, the total rainfall intensity, not intensity, but rather this measure of the erosivity into detached soil particles on average over time, is down here. It's relatively low. I just got a note, Lydia, that my internet connection is unstable. Hopefully you guys can hear me. Bacon County, Georgia, way up here, okay? So we have much greater total rainfall energy and risk associated with Georgia, but look at the difference between, 2 locations in Virginia, right? Sussex County, significantly higher erosion risk, 240 is our R factor versus 140 in Rockingham. So all things being equal, greater risk of sheet and rill erosion as you move, across the state. And what do you also see? The RUSLE2 is now sophisticated enough to take into account the idea that in all these locations, right, the greatest erosion risk as far as climate goes, right, just from the rainfall intensity on average, is in the summertime. And so what that suggests is, on average, spring tillage, everything being equal, spring tillage going into the more intense rainfall season, on average, will lead to more erosion than fall tillage. Of course, some summers we don't have any rain, right? But these are long-term averages. So, where do you get these numbers, Chris? Well, you go into RUSLE2, and I've got a couple different windows open here, but right here, this arrow is showing you, there's your climate data. You open, then this window opens. You can choose what climate you want, choose Shenandoah County. Lo and behold, right in, if you have your databases loaded, which is a whole other lesson properly, but there's your R factor, right, for Shenandoah County. And we've got monthly and daily information, and it's actually right here is where I derived those graphs from. So I actually chose Shenandoah for this picture, but I use Rockingham in the other example. Anyway, they're neighboring counties. But here's the idea: this numeric R factor value, it doesn't show up, right, on RUSLE2 calculation screens. Like this R factor 130, you wouldn't see that unless you drilled in and tried to find it, right? Because you just pick your county. And that's how RUSLE2 in some ways is simpler. There's more happening behind the scenes. But if you dig in, you can find your R factor. So some more take-home points. The R factor in RUSLE2 is based on past weather averages from 1971 to 1999. Again, there's no judgment required for your R factor selection. You just simply select your county, and it pulls up the number, right, for you. Where the judgment is needed is our understanding, right, or interpreting how that R factor impacts your results, okay? And we're going to get into this a little bit more, but think about it, okay? RUSLE2's climate input, right, it's not predicting what's going to happen next year. The weather information that RUSLE2 has is based on a long-term past weather average in terms of how much erosivity there is in your area. And so the best way to think about it is that RUSLE2's prediction is, let's say, a long-term, like a 30-year average rainfall erosivity, right? Because this weather record is just about 30 years long. So assuming that weather record is predictive of what's going to happen in the next 30 years, then that's kind of what RUSLE2 is doing. It's giving us a long-term prediction. And so if RUSLE2's results, right, don't match up with what you see in the field this year or next year, you shouldn't be surprised, because RUSLE2 is not designed to predict next year's erosion. So to highlight that, I thought I would just point out this idea of RUSLE2 becomes more accurate as we take a long-term view, and it's logical. So, let's look at another example, RUSLE2 versus actual climate data for Hanover. And I did this analysis a couple years ago. So RUSLE2 contains information about long-term average past rainfall in Hanover, right? It tells us how much it rained in the past, between basically 1970 and 2000, 30-year period, how much it rained in the past and how hard it rained, the intensity, and when it rained, right, the seasonal distribution. And again, as I already alluded to, these climate assumptions will always basically be wrong if you compare it to a short time frame. But if it can look pretty decent, right, that the information that RUSLE2 does probably is pretty decent if you compare it to a long-term average. So for this comparison, I just thought I'd test out RUSLE2's prediction for total rainfall. It's not the intensity of rainfall. It's not the R factor. It's just what RUSLE2 has in it about total rainfall. Compare that to what was actually observed at the Ashland Airport, each year for a 20-year period here from 1998 to 2017, right? I happened to do this a few years ago, and that's the data I had. RUSLE2's predicted average annual rainfall for Hanover was about 43 inches. When you graph the actual, what you see is that in any given year, we can be pretty far off that predicted average. So for instance, in 2002, we're almost 50% too high. In 2004, we're 20% too low, right? So we're way off on any given year. Or some years we hit right on, right? But there's a lot of variability. But if you take the average of what actually fell in Ashland and in, we'll say, Hanover, the actual 20-year average is about 45. The RUSLE2 predicted was about 43. That's starting to get pretty close. And it's only a difference of by my estimate, about 6% difference, right? So what is that telling us? This is total precipitation, but again, RUSLE2 is actually more interested in the intensity of rainfall. RUSLE2's results, okay, are not valid if you think of them as as predicting what happens next year, okay? And so that's the point that I already made here. When you show these results to people and you look at them, you need to remember this is a long-term average. So last point about climate. You might have noted that the climate data in RUSLE2 is based on data that's already more than 20 years old. So does that bring anything to mind? Actually, I should have had this on a separate slide, but there's a report that came out in 2003, right, from the Saltwater Conservation Society, a national report about the conservation implications of climate change. So back in 2003, right, that's almost 20 years ago, they were saying, we are concerned that storm intensity, because that's what RUSLE2 is interested in. That's what causes sheet and rill erosion, is the intense storms. We're concerned that those intensities may increase, okay? And the question I guess I have for you is, do you think storm intensities have increased? Not amount of rain, but intensity of rain. So here's one example. It's a 2021 study that I happened to find here. And it says that Chesapeake Bay watershed in Virginia have experienced increases in extreme rainfall events over the past few decades, right? So this would suggest that, the climate data in RUSLE2 may not be protective enough, right? It may not be accurately modeling how intense the rainfall is becoming, or even has been over the last 20 years, right? The rainfall data is old. One thing I can tell you with confidence is that the RUSLE2 climate data will not be updated in the foreseeable future. So you're going to need to think about this, right? When you use RUSLE2, the climate data may not reflect our current intensity trends. I'm not saying it does or doesn't. One thing I can tell you is that a new option was made available to me and my fellow state agronomists in 2021. If we want, we can do a customized climate input and do individual RUSLE2 runs with a with a modified climate information. And with that, we could create some case studies potentially to show how climate change is impacting our RUSLE2 results. But you're not going to be able to use newer climate data anytime soon. It's something you as a planner and not a robot needs to keep in mind. All right, folks, well, just fired through the first lesson associated with these different factors. So we're ready for a review question. I'd like you to take a moment. I'm going to take a breath. You take a moment and tell me what you think the best answer is to this question. Okay, folks, so we got about half of you have participated and almost all of you have the right answer. So let me just go over this with you. Okay, and these I'll accept these answers, fun answers. Yeah, where the heck is Aroostook County, Maine? And I could go for some barbecue right now, actually. I could use an early lunch, but these are, no, these are not the answers I was looking for. I was looking for C and D. So let's look at these. Even in case where annual average precipitation rates do not change, erosion risk tends to increase dramatically as you move toward the equator and more tropical climates. Okay, that's true. I explained that. And these numbers show that, right? Not much change in rainfall when you go from Aroostook County, Maine, right, to Rockingham County, Virginia. But your erosion, all factors being equal, erosion risk doubles. And what does that mean? That means if someone from Maine sells their farm and moves to Rockingham County and says, this is just like Maine, except a little warmer, everything they do, even if it's identical, the soils are identical, the management is identical, everything is identical to Maine except the climate, there's double the erosion risk. And I believe that may be part of why the South became so gullied, because we had folks coming from Northern Europe, and what seemed to work there, and coming from the North, what seemed to work there, it just resulted in so much more erosion down here. And the same thing, if you want to move even further south to Georgia, you're going to have an even bigger impact. Okay, so the answer is C and D are both correct. This is a pretty deep dive into some aspects of how RUSLE2 thinks. To me, this is what makes a tool meaningful, is to understand some of what's happening in the background. And by the way, you just learned some things about predicting sheet and rill erosion and minimizing the risk of sheet erosion that you can use without ever opening RUSLE2. So hopefully that's a good lesson. And we're up for lesson 3 now, which is going to the next factor, next input, soil type, or K.